Let's do a few more examples. 3 minus r quantity squared. Let me just restate what these special products are. A plus b quantity squared is a squared plus 2ab plus b squared, and a minus b quantity squared is a squared minus 2ab plus b squared. This one has a subtraction there, so I'm going to be using the difference squared, which means I'm going to take the first value squared, so 9, minus, that's the minus right here, 2 times the first value times the second value. So 2 times 3 is 6, times r is 6r. Then I'll do plus r squared. We get 9 minus 6r plus r squared. Now, this is not in standard form, so I do want to take a moment and rewrite this so it's in standard form. Remember, standard form, degree 2, degree 1, degree 0. The degree 1 term was negative, the negative 6r, so it looks like this. For this example, 9p minus 4 quantity squared. Again, we have a difference squared, so I'm going to use this second form here. I'm going to take that first number squared, so 81p squared, minus, because that's what this says, minus 2 times the first number times the second number, so 2 times 9p is 18p. 18 times 4 is going to give us, what is that, 72? 72p minus, or plus rather, 16. And I know it's plus because it's plus b squared. So you'll notice this negative right here. Normally I would count this as a negative 4 for that term, but I'm not saying this is the second term. B is not the second term here. This is a minus b. B is the thing that follows my subtraction. And so that's why when I'm plugging in b, I'm plugging in 4 rather than negative 4. All right. And this last one, we're taking a sum and we're squaring it. So it's going to be the first thing squared, 4x squared, plus 2 times the product of these. 2 times 2 times 3 is 12. I get an x and a y. Then we'll take this one squared, which is 9y squared. So these special products, the whole point of them is because they are common patterns that you see, and if you can kind of skip a step when you're using these, you can save some work. Now, none of these had to be done using the special products. I could have done 2x plus 3y times 2x plus 3y, and then done my distributive property. I get 4x squared. I get a 6xy rather. Here I get another 6xy, and here I get a 9y squared. When I combine like terms, I get 4x squared plus 12xy plus 9y squared. You can see it is the same thing. And it's important whenever we're doing one of these shortcuts that we always do get the same thing. The whole point of the shortcut is, well, for one, it saves time because it's such a common pattern that you end up seeing. And again, similarly to the difference of squares, this is something, if you were to get into factoring more, if you were to notice this sort of pattern, and you recognize that it ends up being just a plus b quantity squared, this would end up being a time saver later on. And so it's good getting the practice using these special products now when it's a lot easier to recognize this is a sum squared, and to kind of get used to that whole thing, to be able to recognize when this pattern happens later on. It's less valuable if you're planning on going into statistics after this, I suppose, because we don't really, if you're going to Math 115, we don't really do much with, actually we don't really do any factoring in Math 115, but if you are planning on going into Math 95, whether that be because you're going into if you're planning on teaching elementary education, or if you're planning on going into more sciences and maybe going into calculus, then you'll definitely have to do more in the ways of factoring.